Welcome to the online class of mathematics, and this particular class is through online mode due to the certain work for me at home, so that's why I'm not in the class. And today we talk about group theory, which is a course which is a part of BSc first year algebra, and we deal last time we are dealing with group theory as well as another theory, but we last time we have defined group, what are group, and what are certain, and we have also talked about number theory, number system, and today I'm going to deal certain examples of group. So I'm defining the group. What is a group? A set Z with operation certain operation dot. It is a group. I usually denote GP by group. So this is a group if it satisfies following conditions. If it satisfies following conditions. First condition is G is closed. First condition is G is closed with respect to this given operation. Second one is if you have three elements x, y, z belongs to G. If you have three elements, then x dot y dot z, this should be same as x dot y and then dot z, and this property and this particular property is known as a associative property. I should delete it. So this particular thing is known as a associative property. Associative property. And third one is there exists E belongs to G such that E of x, E dot x is equal to x dot E equal to x for all x belongs to G. And this particular condition is known as a existence of identity. And fourth one, it is the bigger point. So what should I write? Okay, fourth one, this particular, and here in the last one, here E is the identity element. This is the identity element of Z with respect to the given operation dot. And what is the fourth one? Now I'm talking about fourth one. And fourth one says that for a given for a given x belongs to Z, there exists a element B there exists a element y belongs to Z such that x dot y is equal to y dot x equal to identity element. X dot y equal to y dot e equal to identity element. In this case, y is known as inverse of x with respect to given operation. And this property is known as the existence of inverses. Okay, so in addition to all these property, in addition to this, इसके अलावा यदि if G satisfies commutative property, in addition to this, if G satisfies commutative property, then this pair G dot is said to be as abelian. Is said to be an abelian group. So it means for Z to be a group, एक G को ग्रुप होने के लिए it has to satisfy four property. First one is a closure property, second one is a associative property, third one is a associative property, third one is the existence of identity, and the fourth one is the existence of inverses. But fourth one is the existence of inverses. And in addition to all these things, if G satisfies commutative property, then we say that it is a abelian group. Now I am going to provide you several examples which are related to this, related to the previous lectures and examples. Examples. Now I am going to deal examples. What are the examples? And because we have already aware about these relations, that set of all natural number is a subset of set of whole number. This is a subset of integers. This is a subset of integers. This is a subset of integer, and integer is a subset of Q, and Q is a subset of R is a subset of C. And here is a strict inequality because there are something on the right which is not in the left one. And because these number system, we have already know about these number systems, and we already have some operations on these sets also, and these operations are plus, dot, multiplication, or dot is a multiplication, so it is already written here, so you can take minus and division. You have several operations here. So I have already suggested some homework for you, that kindly take one set from here and one operation from here, and try to check whether it is a group or not. If it is a group, then why and how you can prove this one, and if it is not, then give the counter example. So it's your duty to verify, because there are several sets, there are several operations. You can verify it so that you become familiar with these operations as well as the concept of group. Now I'm going to deal an important result, which are most important result, and related to, it is related to here also. You know, where is your, okay, you know this R is a collection of all real number, and here is a dot symbol, and if we take whole or with dot, then you can see that this particular collection doesn't form a group with respect to this given operation. There is a reason behind this one, because you know this is a usual multiplication. Now I'm taking the usual one, which you have already know. This is a usual multiplication. A product of two real number is a real number, so there is no issue here. So first one is satisfied. Associativity will automatically satisfied, so there is no problem in satisfying associativity. And what is the existence of identity element? Existence of identity element says that, can you provide me an element in R? Can you provide me an element in R such that, can you provide me an element in R such that if you multiply this element with any element, any real number R, you will get the same thing? Can you have such kind of thing? So I think you have this kind of things. A can be taken as 1. A can be taken. If you take 1 and 1 multiplied with any element, even 0, if you 1 multiplied with 0 is again a 0. So it means it is giving the same thing. So here is the existence of identity. It means 1 is the identity element. 1 is the identity element of R with respect to this usual multiplication. R का 1 identity है. So can you talk about its inverses also? So the reason, you cannot have the inverse of all element. You can have inverse of only non-zero element. If I ask you about the inverse element of 0, so can 0 you have, if you multiply something with b, you cannot have 1, क्योंकि 0 से किसी को भी मल्टीप्लाई करेंगे हमेशा 0 आएगा. हमको ऐसा एलिमेंट सर्च करना जिससे 1 आए, जो कि इम्पॉसिबल है. सो दैट्स वाई That's why we say that here is a element 0, here is a element 0 in R which is not invertible, which is not invertible. Okay, here is an element in R which is not invertible. So it says that R satisfies all conditions except the existence of inverses. So it suggests a thing that if you remove 0 from R, if you remove this 0 from R, then whatever collection you will get, this particular thing forms a group. This particular thing forms a group. You can verify, because you have already verified all these things: closure property as well as associative property as well as existence of identity. The problem was the existence of inverses, and here is only one element, 0, which doesn't have inverse. So that's why I'm removing here 0 and getting R minus 0. People denote it by R star also. Sometime R star means R dot means R star means R minus singleton 0. R minus singleton 0. So this particular collection is a group. Now I'm giving the similar kind of things which are related to matrices, because in 12th class, class 12, you have already know about matrices. So what are matrices? So what are matrices? So here is a little issue, so I'm resolving it. So okay, now I'm giving the next example. Next example says that, suppose I'm taking the smallest example. Suppose you have 2 by 2 matrices over R. I'm taking over R. So what is this? This is a set of all 2 by 2 matrices, 2 by 2 matrices over R. This is a set of all 2 by 2 matrices over R. R के ऊपर ये सारे 2 by 2 matrices हैं. I'm taking this particular plus means usual matrix addition. Plus is a whatever we know, matrix addition and matrix addition. So what are the matrix addition? You know, the matrix addition occurs component wise. I'm taking the component wise matrix addition. So this is a component wise means if you have two matrices, suppose A11, A12 and A21, A22, if you have this matrix and you are adding this matrix with the B11, B12 and B21 and B22, if you are multiplying this one, you will get this one, A11 plus B11, and next entry is a A12 plus B12, second entry is A21 plus B21, and next one is a A22 plus B22. So these are your entries, and we define matrix addition with the component wise, using the component wise in this way. And I'm claiming that this collection of all 2 by 2 matrices over R is a group with respect to this matrix addition. It is a group. So you can verify it. How can you verify? First property, which is a closure property, can be seen from here. You are adding this matrix with this matrix and you are getting this one. This is again a 2 by 2 matrices, and because entries A11 is a real, B11 is real, so sum of two entries real is real, so its entry is also real. Similarly, this entry is also real, this one is also real, so this one is also real. So it means whatever you are getting, that is a 2 by 2 matrices. This particular matrix is nothing but it is a 2 by 2 matrix. It is a 2 by 2 matrix over R. ये R के ऊपर एक 2 by 2 matrix है. Okay, now I'm moving further. Okay. So if you think, because you have already learnt about matrices and you know that matrices satisfies associative property, you can add matrices in any order by grouping in any order. You can add number of matrices by grouping them in any order. So that's why it satisfies associative property with respect to matrix addition. What about the existence of identity with respect to vector with respect to addition here, matrix addition? So you know, can you produce me a 2 by 2 matrix? I'm asking to you, think over it and give me its answer. So can you give me, can you provide me a 2 by 2 matrix such that if you add this matrix with any A11, A21, A12, yeah, it should be A21, A22, and you will get the same thing, A11, A12, A21 and A22. Can you provide me a matrix, 2 by 2 matrix, such that if you add this matrix, you will get the same matrix? And the obvious choice will be, you should be 0 here, it should be 0 here, it should be 0 here, as well as 0 here. Because you can, if you add this 0 with A11, you will get A11. This 0 with A12, you will get A12. So similarly, you can say that this particular thing is a identity. This is the identity. This is the identity element of M2 by 2 matrices over R with respect to this plus operation, and this plus operation is nothing but this is a operation with respect to matrix. This is a operation which is known as a matrix addition. So inverses you can also search for. Suppose I'm asking about something here, 2 by 2 matrices, such that if you add any matrix A11, A12, A22, A21, A22, if you add this particular matrix and you will get 0, 0, 0, 0. Can you give me a matrix such that this is equal to 0? So corresponding to this matrix, you can have minus A11, minus A12, minus A21 and minus A22. and if you add these things you will get 0. It means this particular element is a inverse of what? Inverse of this matrix with respect to the matrix addition operation. With respect to matrix addition operation. Now you have proved that it is closed, means this M now you have proved that this particular collection M2 cross 2R, M2 cross 2R is a group with respect to matrix addition, okay. So this particular collection is a group. So is it a abelian group? My question is whether it is a abelian group or not. My question is whether it is abelian group with respect to this matrix addition or not. So you can verify from the previous one, and previously I have shown you that the multiplication is defined in this way. And suppose if you put this particular matrix, if you put this particular matrix here and this matrix here, you will change the order only. You will get here B11 plus A11. So these are real numbers. So real numbers can be added any order. So you will get the same answer. Similarly here also. So it means this particular collection, whatever you are writing, this is set of all 2 by 2 matrices. This is a not only a group but also abelian group. Now I'm coming to the our main important result. Not only result, it is not a result, but it is a particular example which have a significant importance. Addition modulo. And now I'm going to define addition modulo. What is the addition modulo? So suppose if I denote plus n, so it means it is a addition modulo n. So in particular, if you want to understand something, so take the particular value. Suppose I am taking n equal to 5. So it is the addition modulo 5. So this will be nothing but this will be addition modulo 5. So what do you mean by addition modulo 5? Suppose if you add 3 plus 4. Suppose you are adding 3 plus 4 with addition modulo 5. So what do you mean by this? Its answer will be the remainder obtained by dividing this sum by 5. I'm saying that you can obtain its answer will be the remainder when this 7, 3 plus 4 is 7, this 7 is divided by 5. So suppose 3 plus, in usual addition you will get 7, but in addition modulo 5 you what you get, because 3 plus 4 is 7, to divide this 7 by 5, you will get 5 ones are 5 and you will get remainder 2. So whatever remainder you will get, that will be your answer. So you can imagine that here the situation is not as it is as in the case of usual multiplication or usual addition. In usual addition or multiplication, you will get 7. If you multiply 3, if you add 3 plus 4, you will get 7. But in addition modulo 5, you will get 2. Similarly, one can ask to you, what is the value of 15 in addition modulo, in modulo 5? In modulo 5. 15 की वैल्यू क्या होगी मॉड्यूलो 5 में? So what will be the value of 15 with respect to modulo 5? So it is nothing but it is the remainder when 15 is divided by 5. तो इसका मतलब इसका जो आंसर होगा that will be nothing but it will be the remainder when 15 is divided by 5. So once you divided 15 3s are 5 3s are 15, so you will get remainder 0. So it will be 0. So it means 15 is equal to 0 under modulo 5. Similarly, one can ask to you, what is the value of 7? What is the value of 7 modulo 3? What is the value of 7 modulo 3? It is nothing but it is the remainder when 17 is divided by 3. So divide this 17 by 3. So if once you divide 17 by 3, so 3 fifths are 15. So you will get remainder 2. So its answer will be 2. Okay. So I think now you understood. I hope that now you understood this particular addition modulo. In the similar way, one can define multiplication modulo also. In the similar way, one can define multiplication modulo. Suppose that I am writing multiplication. This is n. So it is nothing but it is a multiplication modulo. It is a multiplication. It is a multiplication modulo n. In particular, again you can take n equal to 4. Suppose that if you take n equal to 4, so what will be the multiplication modulo? So suppose you are multiplying 7 by 6. Suppose you are multiplying 7 by 6. In usual multiplication, you will get 42. 7 6 are 42. Sorry. But if I ask to you, what is the multiplication of 7 and 6 with respect to this multiplication modulo 4? So it is nothing but it is again a remainder when 42 means जो भी multiplication usual multiplication से आएगा उसको 4 से divide करने पर जो भी आएगा that will be your answer. So 4 ones are 4. So it's cancelled. You are taking 2 here, and because there is nothing, so 0. Okay. So you will get remainder 2. So this is your 2. So the value of multiplication of 7 and 6 with respect to modulo 4 is 2. But value of 7 and multiplication of 7 and 6 with respect value of 7 cross 6 in usually you will get 42. So this is a multiplication modulo and that one is a that one was a addition modulo. So using this I am considering this particular example. So what is my example? My example is this collection. I am denoting this. This particular collection is a set of all integers, but here I am denoting, putting n here. Now here I am putting n here. This particular thing is a collection of set 0, 1, 2 and so on up to n minus 1, up to n minus 1, this particular collection. And I'm taking this particular collection, and the operation of which I'm taking here is a addition modulo n. So I'm claiming that this particular collection Zn with plus n is a group, and it is not only a group, it is a group, and moreover it is a abelian group. Moreover, it is a abelian group. Okay, so it is a abelian group. I am claiming that, and one can verify the properties of the group. What are the properties of the group? First property, closedness. Take any two element of this one. In particular, if you take particular value of n, you can have a nice picture of this one in mind. So suppose I'm taking n equal to 5. Suppose I'm taking this. Then you have Z5. Z5 consists of 0, 1, 2, 3 and 4. And you are taking addition modulo 5. Addition modulo 5. Okay. Now I'm taking the addition modulo 5. Okay, now I'm closing this particular thing. You can verify all these things. Now I'm closing.